Welcome in. All right, so in two-dimensional vectors, when you're starting them off in physics, this is probably going to be when you're doing kinematics in 2 dimensions, then you're going to run into the problem of taking just general two-dimensional vectors and then breaking them down into their components. It's one of the easier ways to be able to break down a vector so that you only have x and y components. So basically east and west and north and south, but it will of course depend on whatever reference that you are using. So how do you do that? Well, you do need a little bit of trigonometry. So if you recall your sine, your cosine, and your tangent, and then the inverse of those, then you're pretty much in good territory there. Now I can put up a link up above there to kind of reintroduce you to sines, cosines, and tangents if you've forgotten them. But my assumption is that you have that under kind of your belt and you are comfortable with using those. So if you're not comfortable, then let's use this particular time to try to learn how to break these down. You don't need that much to be able to start breaking down vectors. So in this particular case, we have a vector in the first quadrant, right? So in the xy first quadrant. Now, this is just a reference. It doesn't have to be in this particularly first quadrant. It can be in any quadrant, and we'll take some of those as well and try to break them down. So now, what do I mean by breaking this down into x and y components? So if I take this particular vector and I am given, so I'm going to just kind of bring it back down here, and I am given on what the magnitude is. So notice it's 5 meters, and they give me what the angle is. Now when they say the angle, so this one right here, and they don't mention anything else, it is always with respect to the horizontal. So that means it's this angle right here that is 53.1 degrees. Now once we know that, then the breaking down of these vectors is rather simple. You can break it down into its x component. So it's almost like thinking about rise and run here that you have, okay, for the vectors themselves. So notice this is what I would have, and it would kind of like almost create some kind of a slope that you would carry out. Well, this is your x component, and then this is your y component. Now, depending on what you have, well, in this case, we are measuring, it looks like it's some kind of a position, okay? So you can write them out, not necessarily just x and y. You can be very specific. You can say, this is the component of the position in the x direction, and this is the component in the y direction. Now, if you had these two vectors, of course, okay, so if you took dx and then you added it to dy, so the addition of these two particular vectors, you are going to get that vector, okay? And we're assuming that this one is your position vector that you have. So those additions, okay, of those vectors, and I can put up a link up above there, kind of on the graphing side that I have done this particular video on, okay? So you can take a peek at that in terms of adding and then subtracting, okay, the vectors. Now, our idea is we want to be able to get these two vectors, and then how do we get them out, okay, from there? Well, the rise over the run, if it's already graphed on a graph paper, and you already know what the scaling might be, so let's imagine that, one little kind of, each square designates 1 meter for us, okay, if that's the case, then we can easily find this out by just looking at this, because what we would have is, you would notice that your run, okay, right here, which is your x component, would have been 1, 2, 3. So that would have been the actual piece right there. This is your dx, okay? So this would have been 3 meters, okay, in that particular direction. Now, when it's positive, it means it's kind of like east, okay, or to the right. And then your y component, well, this one is also very easy because it's 1, 2, 3, and 4. Because they nicely fall on the grid, right? So this is your rise, and this would have been your breakdown of the y component. And this would have been 4 meters. Now, to double check for yourself, well, you have done this, right? You have done this most likely in grade 9 and in grade 10, where you've dealt with triangles. So, how do we know, okay, that what we've counted is actually correct? Well, these two pieces, okay, this is a right angle triangle. This is a 90 degrees right there. And we can always find this. Now, this is really just the hypotenuse. So you're now bringing back of the study of the hypotenuse. And if you recall that the hypotenuse squared was equal to, okay, and this was just simply, you know, a squared plus b squared, where a squared and b squared were the actual sides, okay, the lengths of the side. Now, in this case, what we actually have is we have, okay, 3 squared plus 4 squared, which is equal to, so this is going to be 9 plus 16, which is 25. And of course, if you take the square root of this, so if you take the square root of that, you're going to get exactly 5 back. So everything aligns, okay, for us. So that brings back one thing. If you have your components, you can then find what the magnitude is by just simply using, okay, the Pythagorean theorem, right? So finding out the hypotenuse. And it doesn't matter what the triangle is as long as it's a 90-degree triangle. So that's fine. Now, everything here has fallen on the grid, so I haven't really even used any sines or cosines or anything like that. But it's not always going to fall on the grid, right? You're going to have your actual vectors, and they may not fall exactly on the grid. They might be off of the grid, and you may not have a grid at all, where the grid is completely removed. And then how will you be able to do, okay, your counting? So that's what I'm going to do. I'm going to just remove the grid here, just so that you don't see it, okay, and that you're not tempted. Because now if you had this, well, how would you know that it was actually 3 meters and 4 meters? You wouldn't. And that's what you face in a real kind of life study, okay, in situation when you're dealing in physics with various problems and finding vectors. They don't provide you a grid. They might just give you what the vector is. And now they'll say, okay, well, find those components. What's the y component? And then what's the x component? And now you do have to know a little bit. So how do you find them? Well, so if you recall, okay, so in the case, if you know an angle, and this is the angle that we have. Now, in our case, it's 53.1 degrees. So it turns out that the angle that we have is always equal to the opposite side divided by the hypotenuse, right? So that's what it is. This is where those triangles and the definition of trigonometry comes in. Now, here is your hypotenuse, right? Here is your opposite side. So this is the opposite side of the angle. Okay, this is the adjacent side of the angle that you have. So as you're going through, so this is what you would have. Now, if I write these out for you, so if this is the opposite, this is the adjacent, this is my angle right there, okay, and that becomes your hypotenuse. Now you have a relationship between sine of an angle, and it is equal to opposite over hypotenuse. But notice now, when you multiply both sides by h, okay, so this is what you're going to get, you're going to find that the opposite is equal to your hypotenuse multiplied by the sine of the angle. That's what you have. And this is really what you kind of have to think about. And notice that that opposite is your y, right? It's your y component. So this is just your y component that you have in here. So to find out what that is you simply take your actual size, so this is 5 meters, multiplied by sine of the angle that you have in there. You can take out your calculators. You're going to have to find where your sine is, and you can go ahead and compute it. So 5 times, this is going to be sine of 53.1. Just make sure your calculator is set on degrees, all right, so that you're computing this out. And this gives me 3.998, so I guess it's 4, okay, in terms of rounded. For us, 4 meters, and that is the component of y that I have, right? So that is going upwards because it's positive in this particular case. So that's how we actually find that component. Now, if you want to find your component of the x, okay, so that now instead of using sines, well, that's the definition of cosine. So if I go back in there and now start talking about cosine of an angle, it is just equal to the adjacent over hypotenuse. Now notice, from the triangle, here's your adjacent, that's your x component. Your hypotenuse is right there. And again, if you multiply both sides by h, then what you will get is you're going to get h multiplied by cos of the angle, and it is equal to your adjacent, or just simply your x component. And that's what you would have in here. So now computing this out, and I can leave that computation up to you, but if I would take this and I would do the same, so 5 multiplied by, now it's the cos of the angle, which is 53.1, and it gives me, notice, it's 3, which is exactly what we had in terms of counting. But that was because I had the grid, and you don't always have the grid. So this is how you would actually find those components. And in having those components, why do we care about having the components? Because now what we can do is we can take any vector and we can break down any vector in terms of its x and its y components. And then I only have basically up and down, left and right, right? Or east and west, and north and south. And then I can just add or subtract if I have multiple vectors to worry about. So instead of doing things graphically and going head to tail and then actually measuring things out and so on, I can instead break it down into the x and y components and deal with those individually. So I don't want to do that in this particular video where I'm necessarily adding all of these up. But, okay, I do want to be able to break these things down for you, okay, and say that, okay, well, what if we have these vectors? So I'm going to just start off fresh here. So let's imagine I had a vector, right, that was going in this direction. And now I would tell you, so let's say that this is attached, okay, so this is some flat line, and this particular flat line, and I have this vector. I don't know exactly, okay, what the reference might be in there, but I know that this vector, okay, is somewhere with respect to the horizontal, okay, the way that it is drawn in here. And now someone tells you and says, okay, well, this particular vector, now maybe this is not necessarily position, maybe it's your velocity, right? And they tell you that, well, the velocity is, in this case, maybe it's 2.5 meters per second. And this, okay, right here, now all they tell you is that the angle of this, so because it's a vector, so let's imagine that this particular angle, maybe it's something like 35 degrees. So that's what you have. So now, what are you faced with? Well, I don't have a grid. I can certainly bring a grid about, but this is a grid and it would have to be with respect to meters per second. Now, if I wanted to know what the x and y components are, now I have to think about these, okay, and see. So what we would do is we would take this vector, and what we would do is we would create our little triangle. Now this triangle, notice, because this vector, it would have been in the second quadrant in here. So what we would have is, as we would break this down, we would have its pieces, okay, as you're going along. So this would have been, you know, the x component right there that you have, and this would have been your y component that you have. Now, what you know is this is 35 degrees. So you want to know, okay, so how big is this y component? Notice that it is up, so it would be positive. But notice that your x component is to the left. So with respect to the x and y, this actually would have been a negative value because it's to the left. And that's something that we have to think about. Because when we're using sines and cosines, and we're using the interior angle there, and what I mean by interior, this is the interior angle of that triangle, then those values that we're going to get are going to be positive. So be careful, okay, how you are actually going to be drawing these out. And you have to be mindful how to break down the x and the y components. So let's find them. So again, so this is, you can write this out. This is your hypotenuse. Now this is the opposite, okay, side of where the angle is. This would have been your adjacent side right here. So again, if you want to find out your x component, so now in this case, my x component is, so that would have been your hypotenuse, so we would need to know what that is. Well, it's 2.5 meters per second, multiplied by, the x component is the cos of that angle, which is 35 degrees. Your y component would have been 2.5 multiplied by the sine of that angle, which is 35 degrees. And this is where your sines and cosines become really handy. So now what are these? And I guess we're going to round these out, okay, as necessary. So let's see what happens. 2.5 multiplied by the cos. of 35, and this is approximately, 2.05 meters per second. Now, this is up, right? It's positive. So, you can certainly put a little plus to remind you here that it is going upwards, okay? Oh, I'm sorry, it's going to the left because it's the x component. So here, this is great, and notice I've just made the error in terms of thinking it's up. It's x component, so now it's going to be negative because it's to the left, right? So that is the direction of its own, right? Unless you start talking about that maybe it's west, and then you would put 2.05 meters per second west, all right? But if it's with respect to the right, where right is positive, then this would have been a negative number on the magnitude. Now, on the y component, if you take that, this is going to be 2.5 multiplied by the sine of 35, and this one is up because it's with respect to your y direction. So this is 1.43 meters per second that you have in here, and indeed, okay, it is going upwards. So that's what you would have. You would have these two pieces brought in together, and you've just broken down a vector into its x and its y component. And now again, if you wanted to double check for yourself, please remember that if you took these two, so if you took this vector and then you added this vector, right? So you would have went this way, and then you would have put head to tail this way, you would have got your resultant vector back. And you can check that by the Pythagorean theorem. So you can square the x component, add, okay, the square of the y component, and you should get 2.5 back. So that's something that you can double check. So for instance, now of course these are rounded, so it's not going to be exactly, but okay, notice this is going to be, the negative won't matter because if you square a negative, it's going to be positive. So 2.05, this is going to be squared, plus now you're going to take the 1.43 and you're going to square that. Notice you're going to be adding those two together, right? So it's 6.2474, etc. But now you want to take the square root because the hypotenuse squared is equal to this. Now, if we take the square root of this entire thing, so what would that be? So 6.2474. So let me do that, 6.2474. Of course, it's going to be, notice, 2.499, etc. Again, rounded, it's 2.5. What we exactly started with. So this ties in the Pythagorean theorem and then all your sines and cosines. And now you just have to be mindful of when you are given your angles, what angles actually are you being given so that you can do these triangles correctly and then project out onto your x and your y. All right, so let's do one more. So here is one final one, and this one I'll try to trick you in here. So let's imagine now I have a vector, and maybe this particular vector, because I've done everything in terms of first quadrant, second quadrant, let's maybe do this one, and let's put it up and make it downwards, right? So let's say I have something like this, okay? And now with respect to this, maybe this is some 10, and I don't know exactly what this would be. Maybe it's even an acceleration. So let's put meters per second squared. And now I need to know what some angle is. So they would have to give me an angle. And now I'm going to try to trick you in here. I'm going to put it with respect to the vertical. So let's imagine now, okay, so what I would have is that they give me this particular angle. And then maybe, this angle right here is 20 degrees. That's the interior angle. So how do I break down my x and my y components? So here you have to be aware that your little triangle, so notice this is the triangle that you create, okay? So I'll try to make it straight here for us, as straight as I can, okay? So this is one, okay? And then here's the other piece, right? So this is my triangle that I've now created. My hypotenuse I know, so this is 10 meters per second squared, right? This is my x component. This is my x component, and this would be my y component. Now notice your x component is going to be positive, or should be positive, and your y component, because it's down, it should be negative. Now how do you get them? Well, so here the angle themselves, now you have to be careful on which one is opposite, which one is adjacent, because it's always with respect to the angle. So this angle has been given. So with respect to this angle, this is your, so this right here is your opposite angle, right? So this is opposite. And this, okay, with respect to this becomes your adjacent, this becomes your hypotenuse. And this is what I mean, that you have to be careful in here how you calculate this. So in order to find my x, right, the way that it has been written, okay, this way, then with respect to this, I would say this is going to be 10 because it's opposite, so I need sine, and this is going to be sine over the angle. So that actually is going to be my x component. And then my y component is going to be 10, and now this is going to be cos 20 degrees. And this particular cos of the 20 degrees, this one's going to be negative because it's down. So let's calculate these out. So if I take all of this in here, so it's going to be 10. I need my sine of the 20 degrees. What does that equal? So this right here, computed, is 3.42. This is meters per second squared. So that's the component of maybe an acceleration. And it's in the x direction. Just notice it's in the positive direction. And in the y direction, so what you would have is you would have 10 multiplied by sine of the angle, which is 20 degrees. Okay, so in this particular component, and I apologize, I put sine, it should be cos. So this is times cos of 20. And that right there, notice, is 9.39, so I guess approximately 9.4. I'm not worried about rounding here. I'm more interested in you knowing what the components are. So that's 9.4 meters, okay, per second squared. So that's what you would have, but it's down, so this one should be negative. And as you're doing this, you're going to have to be aware, okay, of which angles are exactly given, right, with respect to what, so that you can use them correctly. So that's the introduction here of breaking down a vector into its x and y components. Once we know how to do that, then we can start to add multiple vectors together by simply breaking each vector into its x and y component, and then adding the x and x components together, adding the y components together, and then bringing it all back to know what the resultant vector is. All right, so that is it for this video, and I hope that you do review your sines, your cos, okay, and your triangles with Pythagorean theorem, so that you're comfortable in breaking down vectors, okay, by using those. All right, thanks for watching. See you in a future video. Bye, everybody.